Here's our worksheet on the 4-1 to 4-5 review. Just some quick matching to start off with. An equilateral triangle, of course, has all equal sides, so that's B, versus an isosceles triangle has 2 equal sides, F, and a scalene triangle is G, no equal sides. Equiangular is C, all equal angles. Acute, D, 3 acute angles. A right triangle, A, has 1 right angle, and an obtuse triangle has, looks like E, 1 obtuse angle. So here when I see 3 equal sides, that's equilateral. I'm just going to abbreviate. This one here is no equal sides is scalene. This one with 2 equal sides is isosceles, and that one marked with 2 equal sides is also isosceles. Judging by the angles, when I see 1 obtuse angle, that's obtuse. 1 right angle is a right triangle. Here, this is by the angles. They're all equal, so it's equiangular, and this one's acute. Although I could also say that that one is also acute. Here, when we circle, this one looks like it's isosceles with the 2 sevens and right, versus scalene here and obtuse. This one you can circle equilateral, equiangular, and acute. Here with the 2 sixes, that makes it isosceles, and then it's also acute. This one is really important, and so people get this wrong. The side opposite angle x. Opposite angle x is side YZ. Opposite angle y is side XZ. Opposite angle, what's left is angle Z is side XY. We want to make sure that we use correct notation there as sides. Here the legs are the equal sides, so AB and CB, and the base is the other side, which is AC. Vertex angles, the angle at the top there, angle B, and the base angles are the other 2 angles, angle A and angle C, and by the way, those are congruent. Name the equal sides and equal angles. The equal sides are not 5 and 5, they're side EC, side ED, and that makes angle C and angle D the equal angles. Versus here, the equal angles are angle B and angle C, that creates equal sides AB and AC. So those are a little tricky for people who want to make sure you get the notation right. Interior angles are the angles on the inside. So here this would be angle 1, angle 2, angle 3, and we know that those add up to 180. The exterior angle is angle 4, and the angle next to it is angle 3, and those two also add up to 180. The remote interior angles are angle 1 and angle 2, and angle 1 plus angle 2 is going to equal angle 4. Or you could say the sum of the remote interiors is equal to the exterior angle. You might want to use a calculator for some of these. So we would add like 30 plus 92 is 122, and then we would subtract 180 minus 122 is 58 degrees. In the right triangle, you could do a little shortcut. You could really just say 90 minus 67, because you already have a 90-degree angle. That's 23 degrees. Here I notice they're all equal, so 180 divided by 3 is how I got 60 degrees. Because of z angles, angle 1 is 50. Similarly, angle 2 there is 60. And because a triangle adds up to 180, and I already have 110, angle 3, 70 degrees. These get a little tougher, so you might want to say, well, I have 65 and 77, so if I add those two up, I have 142 degrees, which is actually going to be our angle 2 there. The sum of the remote interior equals the exterior. And then 180 minus 142 is how I'm going to get 38 for that adjacent interior angle. Here all I have to do is add up 109 and 36. The sum of the remote interior equals the exterior. That's 145. And similarly here I just have to subtract 116 minus 81 is going to be 35 degrees. Sum of the remote interior equals the exterior. Got a lot going on in this picture. I notice right away that angle 4 is 90. I notice that angle 5 is 145. Oops, 145 because I subtract it from 180. So 145. It doesn't like it when I write in the corner there. 145. Let's see. This missing angle, angle 3, because triangle has to add up to 180, is going to be 55 degrees. And if I subtract that from 180, I'm going to get 125 for angle 1 and angle 2. Yep. Here, some of these questions you might say like, hey, we saw that question before. You sure did. X is 20. Here, X is 9. here, if I take 180 minus 50 is 130, and I divide it by 2, we had that one before, 65. Here, angle 1 is 65. Those two angles add up to 130. And if I subtract that from 180, angle 2 there is 50. Here, I've got an isosceles right triangle, so that's 45, 45, and 90. 180 minus 40 is 140. When I divide it by 2, I get that angle 3 and angle 4 are both 70, and angle 5, 110, because those make a straight line. This one's going to be 65 and 65 there. If I subtract 180 minus 65, 115, actually for angle 1. And then 65 and 65 adds up to what? 130, so then angle 2 there is going to be 50 degrees. Similarly here, that's going to be 60, so that gives me another 120, which I cut that in half, 60 and 60. Again, some of these were seen on previous worksheets here, that the 2x is equal to 32, so x is 16. The x plus 10 is going to equal 45, because it's a 45, 45, 90. The 5x is 60, x is 12. Now we've got, let's see, really the whole triangle adding up to 180 here. So let's see, what do I have? I've got y plus 5 plus 125 equals 180. Or 2y plus 130 equals 180. So 2y is 50, so y is 25. Here, 3x plus 3 equals 9, so 3x is 6 and x is 2. All the sides are equal. And here, the sum of the remote interior, so those two, 62 plus 84, is going to add up to 2x. Or 146 equals 2x, so x is 73. The next one here is about Pythagorean Theorem. A squared plus b squared equals c squared. It's only used for our right triangles. So we have 10 squared plus 24 squared equals x squared. You want to make sure that you're always setting it equal to the c squared. Some of them we've seen a lot, like this question we've seen a lot. You start to know them by heart, right? 10, 24, 26. Or here, when it's equal to 13 squared, this is going to equal, let's see, x squared is 25 when I subtract, x is 5. And 30 squared plus 40 squared equals x squared. This one's going to turn out to be 50. And really, it's just a multiple of our 3, 4, 5 triangle, right? 900 plus 1600, that's going to be 2500, and then the square root of that is 50. You do have to show the work, even if you know them by heart. Here, they're not going to come out even in this last row, so like 16 squared plus x squared equals 33 squared. You're going to want to get a calculator. I mean, really, this is a math class, and so we're always going to use a calculator because you're not going to know this square root by heart. You could leave it as square root of 833 or as a decimal 28.86. X squared here, well, let's see, this one, the c is the x, so it's 15 squared plus 17 squared equals x squared, or 225 plus 289. So that's 574 equals x squared. And the square root of that, 22.67. Notice I'm always rounding to 2 places after the decimal. So this one here is 225. When I subtract is 56, and the square root of 56, 7.48. So 3 that came out even and 3 that were decimals. We're always going to do this ladder. It reaches up the wall 16 feet. The hypotenuse is always the ladder. So you're just doing that. This is 256 is 400. So x squared is 144. Oh, this one comes out even. That's nice. X is 12 feet. The 26-foot wire is the hypotenuse. It's 10 feet from the ground. It wants to know how high it is. So once you get the numbers in the right spot, right, you're just kind of going through the mechanics of it, 676. And we've done this one a whole bunch where it turns out to be 24, in this case, feet. The length of the diagonal, if each side is 10, the diagonal is the hypotenuse. 10 squared plus 10 squared equals x squared. That's 100 plus 100. So the square root of 200 does not come out even, 14.14. She hikes. She goes 7 north and then 5 west. And then again, you're looking for the hypotenuse. So 25 and 49. So this is 74. 8.60. Could the given sides be sides of a right triangle? Make sure that you have the C as the biggest, right? The C is the biggest. The C is the biggest. So does 4 squared plus 7 squared equals 9 squared? And you have to show the work here. Does 16 plus 49 equal 81? No. But 10 squared plus 24 squared, we know that that's, works out, right? This is 576, and that does equal 676. Does 12 squared plus 16 squared equal 20 squared? That one works too. 144 plus 256, that is 400. Does 20 squared plus 21 squared equal 28 squared? That one doesn't work. This is 400 and 441, and that's 784. If we name other Pythagorean triples, like these work, 3, 4, 5, all we have to do is maybe double it, so like 6, 8, 10, or triple it, 9, 12, 15, or for a third one, I like to multiply by 10, 30, 40, 50. So same thing, if I multiply by 2, 10, 24, 26, if I multiply by 3, 15, 36, and like 39, and if I multiply by 10, 50, 120, 130. Double it, triple it, and then multiply it by 10. I'm just going to multiply this one by 10. And I think on the test you only have to name one more, not 3. For the distance formula, we're just going to count that side's 2, 1, 2, 3, 4, that side is 4. You're always looking for the hypotenuse, which is the c squared. This one's not going to come out even, so you're just going to take the square root of 20, so 4.47. Here you're going to count, this looks like a 2 and a 2. 2 squared plus 2 squared equals x squared. 4 plus 4, of course, is 8. And then the square root of 8, you could do on a calculator, 2.83. We kind of finalize it with that distance formula, which is the same as the Pythagorean theorem, right? But it saves you from having to draw the picture. So we do big old square root, x minus x, so negative 2 minus 3 squared plus y minus y squared. So this is negative 5 squared plus negative 1 squared, or 25 plus 1, or the square root of 26. You can leave it like that, or you can do the decimal. Last one, big square root, x minus x squared plus y minus y squared. So negative 4 squared plus 2 squared, so that's again 16 and 4, square root of 20, 4.47. All right, that's it.